Hello, I talk about equation of a straight line. Suppose I have the straight line passing through this point with coordinates 1, 2. Now when we say equation of a straight line, it is an equation relating x and y that helps us to find what are the possible coordinates of the points of any point on the line. So an equation that if we know the x value, we can use that equation to find the y value, for example. Okay. So let's see how to obtain such an equation. Now we'll make use of what we know about gradients. Now in the formula for gradient, if we know the coordinates of 2 points, then we can find the gradient. Okay, so now we don't know the gradient. So let's say, just for example, let's say the gradient m is given as 3. So we have a line with this gradient, and we know that the line passes through the point 1, 2, that point there. And we let x and y be the coordinates of a point on the line. So what we'd like to do now is to find an equation relating x and y. And we can do that using the formula for gradients. Let me write down the formula again. That's the formula for the gradient. So x1, y1 would be the coordinates of one point, x2, y2, coordinates of another point. So let's now substitute what we know into the formula. So gradient is 3. Now if I call that x2, y2, then I would have y2 minus y1 is y over 2, y minus 2, x2 minus x1 would be, that's supposed to be 1, would be x minus 1. So there we have obtained an equation relating x and y. Alright, and this is the kind of thing that we actually mean, okay, when we talk about equation of a straight line. Alright, it is an equation, an algebraic equation that contains x and y. Okay, and with this equation we can find, if you think of a value of x like say 10, we can use this equation to find the y. So if the x is 10, this equation we can use it to solve for the y, and that will give us the coordinates of that point, for example. And another way we can think of such an equation is to say that, right, since x and y, alright, since the xy of any point on the line must obey this equation, we say that the coordinates of any point on the line must satisfy this equation. Right, so these are the two ways to think about it. Okay, and while we are here, let's make a formula for the gradient, for the equation. All right. Suppose that we have a problem in which we are given the gradients like this, and we are given the coordinates of a point on the line, and we have to find the equation. But we have just seen how to do it, that this is how to do it. But if you want to make a formula for that, this is what we could do. Let's call the gradient m, and let me call the point x1, y1. So instead of numbers, I would replace that with the symbols. So that would be 3 is m, 2 becomes y1, x becomes x1. So in a simple way, I've just turned my answer into a formula that I can use even if I have another question with a different gradient and a different point. So this would be useful. Now the next thing I want to talk about is the different ways that we can write this equation. Now, for example, what do I mean by that? For example, suppose that instead of being given the gradient directly, I'm given the coordinates of another point on the line. So let's say I'm also given a point there. Alright, and let's say that x is x2 and the y value is y2. So suppose that I also know those 2 points, but I don't know the gradient. So this means that in order to use this formula, I must find the gradient first using that formula, and then I would substitute it into here. So, and that's perfectly fine. But sometimes just for convenience, people have made a formula where you can just use directly with this information, and that formula is simply to replace the gradient here by the gradient formula itself. So instead of m, let's just put in the whole lot. So m is actually can actually be this formula, and then that's just the same. Okay, so that then is another possible formula for a straight line that can also be useful. Now, but these two are actually not the most common form of the equation of a straight line, and they're actually quite complicated. Now, I want to take a look at the more common form. Let's start by rearranging that so that it looks simpler. By simpler, I mean, in expressions of algebra, when you see fractions, when you see denominators, it is always more complicated than if there are no fractions. Okay, so let's turn this into something without a denominator. Let's multiply both sides by x minus 1. So if I bring this over to the other side, I get 3x minus 3 equals to y minus 2. Okay, and in mathematics, when we have an equation for a straight line, one common way to do it is to have y as the subject. That means I have y on one side and I rearrange all the rest to the other side. Okay, so this would be 3x comes over minus 1. Now, if you look at this, it looks a lot simpler than that. Okay, or at least it doesn't have a fraction down here. So y equals to 3x minus 1. So this is a more common form than that to show the equation of a straight line. And in this form, let's have a look at the numbers here. There are some meanings to these numbers as well that can help us to understand the equation. Let's look at the number 3 then and think about where it came from. Let's trace it back. 3x came from there. Okay, so the 3 came from there. And the 3x here came from there when I multiplied the denominator by 3. When I bring this over to the other side, that's how I got the 3x there, right? So that means the 3 there came from there. Okay, in other words, the 3 here was actually the gradient. So in this form, when you see a straight line equation in this form, the number in front of x, the number that multiplies the x, that is actually the gradient. That is the m. So that's useful, alright? That's useful to know. What about the minus 1? Now there's one way to understand the minus 1. Think about what happens when x is 0. From the equation, if x is 0, then of course y is minus 1. That's simple enough. But what does it mean on the graph when x is 0? Okay, that's the x-axis, that's 0. Now when x is 0, it means that we are talking about we're looking at the y-axis, because any point on the y-axis must have x equal to 0. Okay. Now since this is an equation of line, it's an equation which any point on the line must obey. So when x is 0 simply means when the line crosses the y-axis. Right? So it's that point that we are looking at. Right? There's this line, x and y can be any point in that, but we are looking at that point when x is 0. So that one, that point that is at the y-axis, that would have x equal to 0. So in other words, according to this equation, when x is 0, y should be minus 1. And it doesn't look like it's minus 1. Alright, in this case, the way I've drawn it is that the point is above 0. Well, that's because I've drawn it very roughly. So this just means that my drawing is not very accurate. Okay, it doesn't mean that the equation is wrong. So I should really rub this away and draw it so that the line crosses below the 0. Okay, so I shan't bother with that. But the important thing here that I want to say is that this line, this minus 1 here, is where the point crosses the y-axis, and there is a name to this point. It is called the y-intercept. Okay, and we usually represent that number by the letter C. Okay, this starts to get confusing. Okay, so in this form, the equation of a straight line is usually written as y equals to mx plus c. Okay. It's getting a bit squeezed down here. Let me try to put this in. So I would write this in the form y equals to mx plus c. So this is a more common form of writing the equation of a straight line, and y equals to mx plus c, and we understand that m is the gradient and c, in this case c is minus 1, is the y-intercept. Now, while we are here, there are actually two other ways of writing the equation of a straight line, or maybe more, but I can only think of two at the moment, that is a bit less common, but that could actually be quite useful for doing questions. I'm just going to sketch out the idea quite quickly. Now in this case, suppose that I have 2 points on the axis A and B. Think about a line that goes through those 2 points. Okay? Now, if a line goes through points A and B on the axis, the equation for the line can be written down immediately as x over a plus y over b equals to 1. Now we can quite quickly see why this equation might be true. For example, if we look at that point there, right? At that point, x is a, and the y value at that point is 0. So if I sub into the equation, I have a over a plus 0 over b equals to 1. And that's true. That's 1 and that's 0. 1 plus 0 is 1. And if I go to that point, okay, x is 0, y is b. If I sub those in, I have 0 over a plus b over b is 1. And that's true as well. B over b is 1. So if you know those two intercepts, the x and the y intercepts, you can immediately write down the equation without having to use those formulas just now. So that is a useful formula to know. Now another form that is also used sometimes is ax plus bx plus by plus c equals to 0. Right, it's a little bit more tricky to understand how this come about, so I will not explain the reason behind this, but what I'll just say is that if you take the number A and the number B down here as x and y coordinates of a point and plot the point on the graph, so suppose that's the point and that's A and that's B. Okay, so A, B and C are all numbers. Okay, before it gets too abstract, let me put in some numbers. Like for example, this might be 3x plus 2b plus 2y plus 1 equals to 0. So suppose that's the equation. Okay. Then, if you take out those two numbers, if you treat the 3 and the 2 as the coordinates of a point and plot that point, you will find that the line joining the origin to the point is actually perpendicular to the line. Right? So that's quite a neat property. Okay, so that's it for equations. So next, let's look at an example where we have two lines that intersect, line 1 and line 2. Suppose we know the equations of these two lines. Okay, and the question is to find the coordinates of that point, the coordinates of the point of intersection. And the idea is this. If you think of any point on that line, the x and y values of that point must satisfy this equation. Now when we say satisfy this equation, that means that if I take the x and y value of any point on this line and substitute them into here and here, then the left hand side must be equal to the right hand side. That means the equation must be correct. Right? So that's what we mean when we say satisfy the equation. So likewise, if there is a point, if there's a point on this line, then its x and y value must satisfy the second equation. At the point of intersection, the point is at the same time on both lines. In other words, the x and y values of the point of intersection must satisfy both equations. So the same x and the same y, when you put it into there and when you put it into there, must be correct. But the equations must be correct. So in other words, we have a problem of simultaneous equation. We have two equations and we're looking at the same x and y in both equations, so we can solve it, right? So let's do this and see what happens. So if we have these two equations and the y's are the same and the x are the same, I can say that since I already have y as the subject, I can say that this is equal to this. So 3x minus 1 is equal to minus x plus 2. Bring the x over, bring the 1 over, and the x equals to 3 over 4. So now I have the x coordinate, that point. So that's 3 over 4. And then I can find another point. So let me sub this into here. So y, for the L2 equation, y is therefore minus of this plus 2. Okay, so that would be 5 over 4. So that then is the y coordinates of the points of intersection. So that's how we can solve a problem for to find the intersection points. Now in this question, we are given the equation of a line. Change here, should be a 1. Okay, and this line passes through the point where with coordinates 2 and 1. Right. So the question is, to find the equation of the straight line that passes through this point and that is perpendicular to this line. So a straight line perpendicular to this, and we want to find the equation. Okay? So let's think about the equation of the straight line, think about what we need in order to write down the equation of a straight line. So we have seen a few examples just now. For example, if we know the gradients, and if we know, say, a point on the line, we would be able to write down the equation. Let me write down the expression just to remind ourselves. So there was this expression, right, where I wrote down gradient is equal to, say, if a point on the line is x and y, and I know a point, the coordinates of x, 1, y1, okay, then this is the gradient, and this equation gives us the equation of the straight line, that one. If we know the gradient. Now in this case, we know the coordinates of 1 point on this line, but we don't know the gradient of this line, at least not yet. But we are given the equation of that line, alright, the perpendicular one. So we should be able to find the gradient from this equation. Now, how can we find gradients from an equation? Well, let's think about the other version of the straight line equation. There was another version, if you remember, where I wrote y is equal to mx plus c. Okay, where m is the gradient, c is the y-intercept. So if I can rearrange this into this form, then I can just read off the gradient. And this form means that y is the subject. So let's do it. 3x plus 1, if I move the minus 7y to the other side, that's what it looks like. Now making y the subject, divide both sides by 7, 3 over 7x plus 1 over 7. So that's it. Now it's in this form, y is the subject. So the number multiplying the x is 3 over 7. So that's the gradient. Okay. Now to find the gradient of the perpendicular line, remember the formula for the gradient for perpendicular line. Right, the one that goes m1, m2 is minus 1, or m2 is minus 1 over m1. So minus 1 over the other gradient. Right, that's a quick way to remember it. So to find this gradient, I must take minus 1 over that gradient. Now that gradient is 3 over 7. Okay, so that means that this gradient must be minus 1 over that. So minus 7 over 3. That's this gradient. So now I know the gradient of this line and I know a point on that line. And I'm ready to use this formula to find its equation. So let's substitute this information into here. M is minus 7 over 3. So that's, draw a line there. Okay, y1, x1, y1 are 2 and 1. Y minus 1 over x minus 2. So that's the equation. Right, and it's usually better to make it simpler by rearranging this into this form. Okay, so to simplify it, we want to get rid of all the fractions. So we would cross multiply the denominators. So let's see. I'm going to keep the minus 7 here, so bring the x minus 2 over. I get minus 7x, and then minus 7 times minus 2 is plus 14. And then 3 goes over there, I get 3y minus 3. Okay, so it looks better now. simplify it a bit more. So for example, if I bring the minus 3 over, I get 3y minus 7x plus 14 plus minus 3, that's 17. So that's a lot simpler. Okay, and usually we would then divide by 3 on both sides and then get it into this form. Yeah, so that's how we can work out this example. Okay, we'll stop here.